Lesson 12.6. It's time to do more difficult logarithms. So at this point, you have done the basics of solving logarithms. You've realized that there are really only two options. That has not changed. Your goal is either to be able to drop the logarithms because you have a log on each side, so then you don't need it anymore. That's option one. Or option two, you condense each side, ideally this one side, and you would have, the logarithm, um, yeah, that you could then, once you have one logarithm, loop swoop, 2 to the third equals what? So then 2 to the third, that's a 3. 2 to the third is 8. So those are your two options. Now, it's going to get a little more complicated than that because we have to do some condensing and get a little creative sometimes. But for the most part, it's not too terrible. And it really does boil down to one of those two options. Okay, so one thing before we get started. It is possible for you to have extraneous solutions. Now, we did extraneous solutions a lot of times throughout the course of the year. Most recently, we did extraneous solutions with solving rationals. So, just in our last unit, Unit 11. So, for solving more difficult logarithms, I need you to know that you're going to have to check your answers. And that can get frustrating because you've already spent a lot of time solving your questions, solving your equations. Now, it's always important for you to know why you get extraneous solutions. Remember that a logarithm looks like this. It has a vertical asymptote that is like really thick. It has a vertical asymptote along the y-axis. And also notice that there is nothing over to the left. You don't go past that vertical asymptote. So your base, whether it's a growth greater than 1 or a decay in between 0 and 1, the parent will never go to the left, to the negatives. So what I'm trying to tell you is you have two things that are going to be an issue. One, you can't take the logarithm of 0. Why? Because there's an asymptote. Two, you can't take the logarithm of a negative number. Why? Because there's no graph over there. It doesn't exist. Now the question is, why doesn't it exist? So, your first option, why can you not take the logarithm of 0? Let's say we picked any base. Let's just keep it common. Let's keep the common logarithm of base 10. So if I asked you to evaluate this, if I said, okay, what is log base 10 of 0? What you need to recognize is that that doesn't exist. It's not going to happen. So why doesn't it exist? Well, think this through. 10 to the what equals 0. Someone's going to think, oh, the exponent is 0, the answer is 1. Okay. If the exponent is 0, isn't the answer 1? You just said it. It's not going to happen. So then someone says, well, what if it's 1? Okay. What is 10 to the first? Is 10 to the first 0? No, 10 to the first is 10. Again, that doesn't equal 0. Someone might say, okay, what about negative 1? All right, that's 1 over 10. In any of these options, are we ever going to get a 0? No, we're not. It's not going to happen. So you can't take the log of 0. It literally doesn't exist. Can't do it. Now, the other option, you cannot take a log of a negative number. So, and that's any negative number right there. So if you had something like, we'll keep it with log 10. Log base 10 of negative 100. This is a common misconception. So log base 10 of negative 100. Why can't you evaluate that? It doesn't seem like to be that big of a deal. Someone's going to say, oh, well, that's easy. 10 to the what equals negative 100. 10 to the what equals negative 100. Someone is bound to say, oh, it's -2. Mm-mm. A negative exponent sends it across the line and changes the sign. That doesn't make a -100. Oh, and actually that would be squared. So it's 1 over 100, not -100. That's not correct. That's not equivalent, clearly. Someone might say -1. That's going to be 1/10, not 100. Not -100, excuse me. Someone might say 0. And with the exponent of 0, the answer is 1. All of these things, none of them are going to get you anywhere to -100. It's not possible. So, moral of the story. Let's make this so it's easy to read. Okay. If you find yourself taking the log of 0, whatever your base is, doesn't matter. But if you find yourself taking the log of 0, in this case, base 10 of 0, it's not possible. You have to understand that what you've got as your answer will not work. So whatever your answer is, if it makes whatever you're taking the logarithm of 0, if it makes this happen right here, it's extraneous. It's not going to exist. Now, if you take the log, no matter what the base is, of a negative number, we have this same problem. That can't be done. So whatever value you think you got to make that happen, it must be extraneous. Why? Because logs of negative numbers don't exist. So let's go to an actual problem, keeping that in mind. Okay, I'm actually really frustrated that this is the one I chose to go first, because it's a doozy. It's a big one. Now, getting started isn't the problem. It's finishing it that's going to be the tough part. Remember that the goal is one of two options. Either you have logs on both sides that you get to drop the logarithms, or you have one log that you can loop swoop to change it to exponential and actually solve it. So your first goal should be get logs together. Now, that's the easy part. This becomes log base 3 of, remember, whenever you're adding, you condense back through multiplication. And when you multiply the variables, you add the exponents. That's base 3. So, easy. We have the same log on both sides. We drop the logarithms. So then the real question is, how do you solve y to the 5th equals 16y? Well, I know, yay, it's exciting. You've got a couple options. Well, for starters, if you're going to factor, because you find yourself with y to the 5th and y, you would have to get everything together on one side. You would then factor out the GCF, which is 1y. That leaves you with y to the 4th minus 16. That is a perfect square minus a perfect square. That is the difference of squares, my favorite. So I'm going to just put this up here off to the side. We've got y. We have y to the 4th minus 16. So if you take your y to the 4th and your 16, a perfect square minus perfect square. Well, the square root of y to the 4th would be y squared. The square root of 16 is 4. And remember, 1 gets a plus and 1 gets a minus. This one can't go any further because that's a perfect square plus perfect square, and you can never factor those. But this one is yet another difference of squares. Y squared plus 4, okay? So then this becomes y plus 2, y minus 2. Finishing this is a piece of cake, except for when it comes to this one, which is not too terrible. It's just you're not going to like it because it's going to give you an imaginary. Let's see what I mean. If you set each of these equal to 0, there's one of them. There's another. third. Remember what we learned about polynomials? Biggest exponent is how many you're looking for. We've got 3 out of 5. So where are the other 2 coming from? Well, if you set y squared plus 4 equal to 0, and you subtract the 4, when you force the square root, you have to show plus or minus. That's always going to happen. And what is the square root of negative 4? 2i. It's imaginary. Did we get 5 solutions? Yes, we did. 2 of them aren't real. They're imaginary. But 3 of them are real. Now here's the last part of this. This is the part that's going to stink. Oh, here we go. There's no point in checking the imaginary, right? The imaginary is a non-issue. It's not on the coordinate plane anyway. But you still have to check the 0 and the plus or minus 2. When you do that, and you plug in to all of these y's, do you see that it only takes 1 to cause a problem? And right off the bat, we have 0 squared, which is 0. Can you take the log of 0? We just talked about it. The answer is no. So 0, it makes it extraneous. Now, let's check negative 2. When I plug in negative 2 right here for y squared, it makes positive 4. So far, we don't have an issue. But as soon as I plug it in here, and of course also here, but it only takes one of them to be a problem, that becomes negative 2 to the third. That is taking the log base 3 of negative 8. Can you take the log of a negative number? You cannot. So that one is also extraneous. We plug in the 2, and the 2 finally works. So we do have a winner with the positive 2. Let's check it really quick. If I put the 2 in for all those y's, I have log base 3 of 2 squared is 4. I have log base 3 of 2 cubed is 8. And that is supposed to equal log base 3 of 16 times 2 is 32. When you condense these, you condense through multiplication because you have a plus sign, and that means you're going to multiply whenever you put them back together. So that would be 8 times 4 is 32. Is log base 3 of 32 equal to the right side log base 3 of 32? Yes, it is. So positive 2 works. Everything else, not worth your time. But you didn't know that until you actually grappled with it and did all the math to get there. I get that it's tough. Not impossible, but tough. So, what about this guy? Example 2. I actually really like this example. It's actually pretty quick and easy. Hopefully you've noticed that all you got to do is condense and then drop. The natural log of 2t plus the natural log of 3t. When you have condensing with addition, you will multiply to do that. So what is 2t times 3t? Well, it's 6t squared. The natural log of 6t squared equals the natural log of 24. This is option 1. You get to drop the logarithms, and then you just have to solve. You could take that over and factor it. That's very fine. That's very possible. It's totally fine. But remember, you really need to factor when you have like x and x squared. Well, we don't have any x. We just have x squared or t squared. So you can actually set them up to solve this one. You don't have to factor, even though you could if you wanted to. T squared equals 4. Force the square root, so t equals plus or minus 2. So let's check them. What's it going to be? If I check t is 2, you have, here's my check. The natural log of 2 times 2 is 4. The natural log of 3 times 2 is 6. And that is supposed to be the natural log of 24. When you condense these with multiplication, 4 times 6 is 24. So positive 2 works just fine. Now what about negative 2? When I plug in a negative, I start off with a problem right away. Good news is once you see it, you don't have to go any further. When I plug in a negative 2 in for t, I'm taking the logarithm of negative 4. That does not exist, making this guy extraneous. Can't do it. As soon as the first mistake happens, the first issue happens, you don't have to go forward. You don't have to keep going, which is nice. What you have to be comfortable with is knowing what it means to be extraneous. If it gives you a 0 or it gives you a negative, you're done. Okay. Example 3. Hopefully by now you're catching on. Condense and drop the logarithms. When I condense, I don't know why I just said t. I forgot what I was doing for a second. Log base 5. How do I put together t and t minus 4? Remember, you're multiplying whenever you condense through addition. So that is t squared minus 4t equals log base 5 of 21. So now that the logs are on each side, and there's just one log and one log, I can drop them. So what I really have to work with is t squared minus 4t equals 21. That is factorable, but of course to do that, I would have to notice that I need to subtract 21 to get 0 on one side, and then go from there. Factoring, yet again, never goes away. The good news is you're finally really good at it. You've been working really hard. You've come a long way this year. I'm really proud of you guys. So the factors of 21, negative 21 that give me negative 4, would be negative 7 and positive 3. We set those equal to 0 and solve. So t equals positive 7 and t equals negative 3. So now the question is, which one is going to work, which one is not? Or, in an interesting twist, will they both work or will they both not? You won't know until you check them. So let's check the 7. Log base 5 of 7 plus log base 5 of 7 minus 4 is 3. That is supposed to equal log base 5 of 21. That's a 5. Do these condense back through multiplication to give you 21? Yeah, 7 times 3 is 21. 7 is a winner. Negative 3. Right off the bat, we plug in the negative 3 for t, and we already have a problem. You can't take the log of a negative number. Now, please be advised, that doesn't mean you can't have exponents that are negative. Whenever we're doing exponentials in the next lesson in 12.7, you will see that you can have negatives. It's not a big deal. Mostly because in exponential format, that's just sending it across the line, changing the sign. That's not a problem. It's the logarithms of negatives. That's what you can't do. It doesn't mean your answer can't be a negative either. That's the funny part. If this was a negative t, this one would be the extraneous one. Because when I plug in the 7, I would have had log base 5 of negative 7. If I had plugged in the negative 3, right here, I would have minus negative 3, which turns it back to positive 3. So there are circumstances whenever the negative is not the issue. Again, you won't know until you actually put pencil to paper and try it. Okay, one that's a little bit different. We're going to condense both sides. We've got to condense the left side. We've got to condense the right side. When we condense both of these and they have subtraction, how do you condense when you're subtracting the logarithms? Subtraction condenses through division. And the one that you see first is the numerator. And the one that you see second that's being subtracted is the denominator. So we've got the natural log of y minus 3 over y minus 4 is equal to the natural log of y plus 3 over y. Well, now you can drop the logarithms. Y minus 3 over y minus 4 equals y plus 3 over y. In Unit 11, we just finished solving these. You could cross multiply. You could make the denominators the same and drop the denominator. You got options. So what's crazy is I've told you all year long, math builds. Yet again, case in point, it's still building. We just finished how to solve when you have a variable in the denominator. So what do you want to do? If you cross multiply, you've got y times y minus 3. So y squared minus 3y. And that will be equal to, when you cross multiply the other diagonal, you'll have y minus 4 times y plus 3, which is y squared minus 1y, because the o and the I in FOIL give me negative 1, minus 12, which would be the L in FOIL. So the first, the outer, the inner, and the last. If you had decided to figure out that the LCD was y times y minus 4, you would have given that y, and you would have done the same to the numerator, keep it balanced. You still would have ended up right back here. And this one you would have given y minus 4 and y minus 4, and you would have ended up right back here. So it doesn't matter if you cross multiply or give it the LCD. Whenever it's two ratios that equal to each other, it's going to be the same thing. So let's finish it out. I need to get my y squareds together. It looks like, because I've got y squared and y, it looks like that I'm going to start to FOIL, or factor, excuse me. So I need to start getting things together. Now what ends up happening on this one is that as soon as you start moving things around, oh look at that, y squared's gone. So I need some more space, so I'm going to go up here. So we've got negative 3y equals negative y minus 12. Well, I don't have to factor anymore. I can SADMAP because I just lost my y squared. And that ends up being negative 2y equals negative 12. So y equals positive 6. I only got one answer. That's fine. There's not a big deal with that. So let's see if it's true. When I check it, the natural log, y minus 3, so 6 minus 3 is 3, minus the natural log of 6 minus 4 is 2. That is supposed to equal the natural log of 6 plus 3 is 9, minus the natural log of 3. I'm sorry, it's 6. I'm checking. Of 6. When these come together, that is the natural log of 3 divided by 2, so 1.5. When these come together, when we condense through division, that is the natural log of 9 over 6. Isn't 9 over 6 the same as 3 over 2? It checks out. Totally works. I'm clipping along pretty fast because I don't want this to take forever, but you need to see how weird these things get. They're not terrible, but some of them are a little more challenging than others. The more you do, the better you'll get, and the faster you'll get. So hopefully you're keeping up just fine. Okay, so here's going to be finally an option 2. In the beginning of this document, I don't know if I still have it up there or not. No, I don't. Okay. I had option 1 and option 2. Option 1 being logarithms on both sides, you get to drop. Option 2 being you only have logarithms on one side, you'll condense and you'll loop swoop. You'll change it to exponential to solve it. This is that problem. So if we condense the logarithms and we have addition, we'll be condensing them through multiplication. So I've got 3x times x, 3x squared, and 3x times negative 4, negative 12x. That equals 2. So what now? Well, now that we have one logarithm and we're doing the second option of how to solve logs, not the first, because you can't drop the logarithms when they're not both on each side, your only option is to loop swoop, to change it from bay to bia. So the base to the exponent equals the answer. So 6 to the second equals 3x squared minus 12x. Awesome, easy. So that would be 36. I then need to subtract 36. So I can now factor out a 3, leaving x squared minus 4x minus 12. I can then factor that further. I took out a GCF, but the factors of negative 12 that give me negative 4 would be negative 6 and positive 2. Set everything equal to 0. When I set 3 equal to 0, there's no x, there's no answer. So remember what this is really is mathematically that would be a stretch by 3, vertical stretch by 3. The next one, set x minus 6 equal to 0. That would be if it were quadratic. I might be talking out of turn, so I apologize. X plus 2 equals 0, so x equals negative 2. And now we check for extraneous to see if one works and one doesn't. When I plug in the 6 times 3 is 18, so we have log base 6 of 18. We have log base 6 of 6 minus 4 is 2, and that's supposed to be the answer 2. Here we go. When you condense these, you have log base 6 of, well, 18 times 2 is 36. Is 6 to the second equal to 36 when you convert it to exponential form? Yeah, totally is. Positive 6 totally checks out. Now, let's try negative 2. Hopefully you're catching on really fast and that it's automatically out. Not because it's negative, but because it would make negative 6 right there. Just to start off with, you would have a problem. You'd have an issue. So it's out. Which one are we on? Number 6, it looks like. Number 6, let's condense. Get it to 1 logarithm. That means I actually have to FOIL that. That would be x squared. Negative 5x and positive 2x makes negative 3x. And then negative 5 and 2 make negative 10. Okay. Now that we have it to 1 logarithm, it's clearly going to be an option 2 situation. So 8 to the first equals, I just did the loop swoop, equals, what am I writing? X squared minus 3x minus 10. Well, 8 to the first is 8. So how do I solve this? Everything we've been doing pretty much leads to factoring. So x squared minus 3x minus 18. That's an 18. What are the factors of 18 that give me negative 3? A negative 6 and a positive 3. So x equals positive 6, x equals negative 3. Negative 3, I can already tell you, is going to be out. It would make this right here negative 1. You can't take log base 8 of negative 1. Negative 3 plus 2 is negative 1, so that's out. Let's see if 6 works. Log base 8 of 6 plus 2 is 8, plus log base 8 of 6 minus 5 is 1. Is supposed to equal 1. If I condense those, log base 8 of, condensing through multiplication means that becomes and stays an 8. 8 times 1 is just 8. So then the question is log base 8 of 8 equal to 1? The shortcut from a previous lesson tells you that when those are a match, they kind of quote-unquote cancel and whatever you have as the exponent drops down. But even if you didn't notice that, you could still loop swoop it and get the same thing. Isn't 8 to the first equal to 8? Loop swoop worked. 6 is good. Negative 3 does not work. Okay, we are on example 7. We've got 4 more to go. We're going to condense this time through division because we have subtraction. So I've got 9x plus 5 over x squared minus 1. That is supposed to equal 2. When you loop swoop here, you've got 2 to the second equals all that business. 2 to the second is 4. Okay. You could make that 4 over 1 and you could cross multiply. You could leave that as just 4 And the first thing you could do then is get the variable out of the denominator by multiplying by x squared minus 1 and keeping it balanced on both sides. Those would go. You would have 4x squared minus 4 equals 9x plus 5. You have x squared and x, so you're going to have to factor. So I need to get everything together on one side, so that 0 is on the other side. 4x squared minus 9x minus 9 equals 0. Believe it or not, that is factorable. If you were to do swing and divide, you would have 4x and x, and that'd be 3, because that would make 12. I need a negative 12, and then positive 3 would give me the negative 9 when I multiply, and then the negative 9 in the middle whenever I combine negative 12 and positive 3. Yep, good. Do I need to refresh swing and divide one more time? I might as well. Okay, you swing, aka multiply, and it's not really, I guess I keep on calling it swing and divide, but it's not actually swing and divide. I think it's just factoring by grouping, I think is the right way to say it. So negative 36, the factors of negative 36 that give me negative 9 would be 3 times negative 12. And when I plug that back in, 4x squared plus 3x minus 12x minus 9 goes in here. And yes, those are x's, I forgot, because that's x squared. So then we break it up by grouping. The GCF of 4x squared plus 3x would be x, leaving 4x plus 3. The GCF of negative 12x and negative 9, negative 3 goes into both of those, leaving, shock of all shocks, 4x plus 3. You see it? And then we end up with writing the duplicate one time and the leftovers together to finish that out. Okay, I'm going to get rid of this because I need the space. So then to finish this out, by setting this equal to 0, on the 4x plus 3 equals 0, I'm going to subtract 3 and divide by 4. So x equals negative 3/4. And then, of course, over here, I'll just add 3. X equals positive 3. So let's see if anything is extraneous. Using the original equation, I'm going to have to get a negative 3/4. Let's go see. Okay. So if I plug in a negative 3/4 here and here, so sorry, excuse me. Well, let's see, negative 3/4 times 9 plus 5. So log base 2 of 9 times negative 3/4 to be plus 5. I'm going to have to subtract and then I'll have to keep going. Well, negative 3/4 times 9 is negative 27/4. When I add 5 over 1, I have to get a common denominator. So I have negative 27/4 plus 20/4, which equals negative 7/4. Sweet, that means this one is out. I don't have to do anything else with that. You can't take log base 2 of a negative number. You can't take the log of a negative number, negative 7/4 in that case. When I plug in 3, let's see what happens. 3 times 9 is 27. 27 plus 5, is 32. So we have log base 2 of 32. When I plug in positive 3 on that side, 3 squared is 9 minus 1 is 8. Log base 2 of 8. It's supposed to equal 2. When I condense those two, log base 2 of 32 divided by 8 is 4, because you condense through division. It's part of your log properties. So is, in fact, 2 to the second equal to 4? Yes, it is. So positive 3, it worked just fine. Now this is a bit of a mess. Take that information away. Let's see. What are we on? Number 8? Yeah. Okay, example 8. I want to remind you that when you don't see a base, you know what that means. It is the common logarithm is base 10. You just see the word log is base 10. If it's a different base, it'll tell you, like base 2 or base 5 or base 0.5 or whatever you want to do. Okay, so here we go. If that is really a base 10, 10 to the 0 equals all that business. 10 to the 0 you should recognize. When the exponent is 0, the answer is 1. So I'm glad we didn't do too much with the x because that would have been frustrating to be a waste of our time. It's pretty quick and easy. We will subtract 1. And factor to finish. Interesting. I can't factor that. Oh, this is very interesting. If I can't factor that, I'm going to have to do the quad formula. And everybody just went, oh, not the quad formula. Let's see what happens. A is 1, B is 2, C is negative 1. X equals the opposite of B, plus or minus the square root of B squared, positive 4, minus 4 times A times C. All over 2 times 1. So we've got negative 2 plus or minus 4 plus 4. This right here is a negative 4 times 1, which is negative 4, times negative 1, which is positive 4. So you end up having 4 plus 4, which is 8 over 2. So you've got negative 2 plus or minus 8, the square root of 8, excuse me, over 2. Well, 8 is 4 times 2, which is then square rooted is 2 root 2. So we have negative 2 plus or minus 2 root 2 over 2. Everything can reduce. I take out a 2 from each of those. So negative 2 divided by 2 is negative 1, and 2 root 2 divided by 2 is just root 2. So you have two different answers. We have negative 1 plus the square root of 2, and we have negative 1 minus the square root of 2. I am going to take this opportunity because I really do not want to work with those values by hand, if I'm just being 100% honest. So I want to take the opportunity to refresh how your calculator can also help you streamline this process when you check your answers. So we're going to check this on our calculator. Okay. So in our original, and you can do this whichever way you want to do this. You can do this by typing in and storing in for x. If you want to store in the entire thing, you have negative 1. Let's see. Negative 1 plus the square root, control x squared, of 2. And we're going to store that in for x. Okay, so that decimal is stored in for x. And then I'm going to type my original equation. My original equation is log base 10 of x. That's my logarithm. Okay, and then I'm going to get out of that on the side. I'm going to add it with log base 10 of x plus 2. X plus 2. That is supposed to equal 0. And you can do this either way. You can finish this out and you can actually do your test feature of equals 0 and it tells you true. Or you also could have done you could have just hit enter and see if it gave you 0. Either way, just make sure you know that that's not the binary code 0 where it's saying no, it's extraneous. That is very much true. It actually works. So the -1 plus the square root of 2 worked just fine. Now let's try the -1 minus the square root of 2. So I'm going to keep this easier, and I love how it has this feature. I'm going to take the -1 plus the square root of 2, I'm going to copy it by hitting enter, and I'm just going to go back and change the plus to a minus. So now that's stored in, and then I'm going to go to this one because I want to see if it tells me true or false. And, oh, non-real calculation. So take a guess as to what an error message means. Surely you're guessing that that means it's extraneous. So we had one winner and one not so much. Okay, how many left we got? 2? We can do this. Whoa, excuse me. Home stretch. I'm sorry it's getting so late. Okay. Oh, yay. That's fine. All right, a couple things you need to notice. Yes, you will condense this side through multiplication because you have a plus sign right there. But you also have to recognize that you have a 2 in front of the natural log. And anytime you have a number in front, that's an exponent. Remember, it's a power to a power multiply the powers. So if you expand it by taking the cute little exponent and dropping it down front, to condense it, you put it back. So this 2 is going to go up right here. So I have the natural log of 2y plus 2 squared equals this 2 has to also go up, and then we will also condense them. So it looks to me like I have 16 times y minus 2 squared. Now, you can drop the natural logs right now, or you can wait until you FOIL everything out. It's not going to matter. You should be able to tell me that 2y plus 2 squared is writing it twice and FOILing would be 2y times 2y is 4y squared. 2y times 2 is 4y, excuse me. The 2 and the 2y is another 4, making 8. And then 2 and 2 makes 4. It may have been more simple just to write it out, y'all. I'm sorry. It's getting late and I've had a long day. So 4y squared, shoop, that was this one. And then there's that one, that's plus 4y, that's plus 4y, and that's plus 4. So that's where the 8y came from in the middle, in case you were curious, because I was just verbalizing and not actually showing you. So then over on the right, y minus 2 squared is y minus 2 times y minus 2, which is y squared minus 4y plus 4. Y squared minus 2y minus 2y, and that makes the negative 4y in the middle, and then positive 4. So all of this has the 16 next to it. So this one over here on the right-hand side would be 16y squared minus 64y plus 64. Okay. We finally have one logarithm and one logarithm. We get to drop the logarithms. We have a whole big mess of a whole bunch of variables, but you should have a trigger Your clue is that you have y squareds and y's. So let's get them all together because then we're going to factor. So I'm going to subtract 4y squareds. I'm going to subtract 8y. I'm going to subtract 4. So 12y squared minus 72y plus 60. There is, in each of those, if I'm going to continue factoring, there's a 12 that can come out of that. 12y squared is 12 times y squared. 72y would be 12 times negative 6y, and 60 would be 12 times positive 5. So then 0 equals 12, and then I can take what I have left and factor to finish. The factors of 5 that give me negative 6 are a negative 5 and a positive, a negative 5 and a negative 1. So when I set all of these equal to 0, well, 12 equals 0 doesn't make any sense. No x, no answer. It's just a stretch, right? Y minus 5 equals 0, so y equals positive 5. And y minus 1 equals 0, so y equals positive 1. Okay, we can't check this one because it's not an answer in the first place. We do need to check the 5 and the 1. Here we go. Whew, that's a lot. That's a mess. I'm going to need, I'm kind of tempted just to type it in when it gets this complicated. I'm going to do it. I'm going to show you how to do that one more time. Even though I totally could do that by hand, and I've already proven to you that I can do it by hand, of course. I just don't want to. So I'm going to say we're going to store in 5 for x. It's okay that you're using x versus y. It doesn't make a difference. So we're going to store in 5 for x. Okay. And then I'm going to type 2 times the natural log, and the natural log has its own button with the e attached to it. 2x plus 2. That is supposed to equal the natural log of 16 let's get out of there, plus 2 times the natural log of x minus 2. True. 5 works. So now I'm going to store in 1, and I'm going to highlight and copy. So I'm checking x equals 1, or y equals 1, I guess is the equation. Copy it. Ooh, we got a problem. There's the false, so it means extraneous. So the 5 works just fine when I put it in the calculator. The positive 1, so here's an example when it's not a negative, it's a positive, and it still doesn't make any sense. In fact, you could have seen that because it's right here where the issue is. 1 minus 2 is negative 1. And if you can't take the log of a negative number, you can't take the natural log of a negative number either. Last example, if you're still with me right now, kudos to y'all for sticking it out to the very end because this has been a long lesson. 10 examples of some really tough problems. It's a big deal. I get that. Okay, here we go. So we start by noticing these 1/2s. They need to go up where they belong because they're cute little exponents for a power to a power. So we have log base 3 of c plus 1 to the 1/2 plus log base 3 of c minus 4 to the 1/2. And that's going to equal log base 3 of 6. That's a 3. I'm making it worse. So you notice, I'm hoping that you notice, that the 1/2 power, remember, that's really a square root. Both of those are square rooted. And whenever you condense through this addition right here, you're condensing through multiplication. And when they both have a radical, you can put them both together under the radical. So as complicated as it looks, that just ends up being the square root of the c plus 1 times the c minus 4. Now, I might have to FOIL all this out to end up using it, but that's fine. It's fine for now, just left like that. So we have the logs on both sides. We get to drop them. Oh, look, I was right. Okay. So we've got, let's see, I'm going to go ahead and do it. C squared minus 4c plus 1c is minus 3c. And then 1 and negative 4, minus 4. So this equals 6. Not a problem. You did solving radicals like this in Unit 7-8. It's been a while, but it was this semester. So we're going to start by getting rid of the radical by squaring both sides. Got to keep it balanced. So the square root and the square cancel, and you have c squared minus 3c minus 4 equals 36. Well, I've got c and c squared, so the odds are I'm going to have to factor. So I'm going to get everything together on that side. C squared minus 3c minus 40 equals 0. The factors of 40, negative, that give you negative 3. A negative 8 and a positive 5 would FOIL back out to get that negative 3 in the middle and that negative 40 on the end. So then when I set these each equal to 0, I'm going to add 8 and subtract 5. So I've got c equals 8 and c equals negative 5. Let's check them. It's tempting to just go for the calculator again. But that's okay. Let's make sure you see how to do this in case you don't have a calculator on that part of the test or a quiz or something like that. So 8 plus 1 is 9. 8 minus 4 is 4. You can probably hear Bennett in the background. Kevin should be getting her because it's bottle time. And I'm so sorry. I'm not going to restart the whole video for that last part on the last problem. I'm so sorry, y'all. Okay, so what do we have? We have different ways of doing this. Okay, so the 1/2 can go up with the 9. So log base 3 of 9 to the 1/2. Well, that's really the square root of 9, right? 9 to the 1/2. So the square root of 9 is 3. And in here, this 1/2 goes up there. So we've got log base 3 of 4 to the 1/2, which is really the square root of 4. The square root of 4 is 2. And then we have log base 3 of 6. Check it out. When you condense them back to one logarithm, you have to multiply, and 3 times 2 is 6. So the 8 totally worked just fine. Now, the beauty of the negative 5. Automatically going to be extraneous, because as soon as I put it into the problem, I begin with the log base 3, 1/2 log base 3 of negative 5 plus 1. And negative 5 plus 1 is negative 4, and you can't take the log of a negative number. Boom. Okay, you made it. I'm proud of you. Thank you for sticking with me. If you made it this long, you're doing great. You're going to have to practice. But I have full confidence and full faith that you can do this. So, talk to you soon.